Now we're going to solve this equation. This equation involves a radical, clearly. So what we're going to do is, what we always do with these, is we isolate a radical. So let's get this radical by itself, say on the left side, since it's already here. We can do that if we just add 6, right? So the plan here is to add that 6. So if we do that, that'll give us the square root of 7y plus 1 equals, now add 6 to both sides, we'll get 6. Now we can eliminate that square root if we square both sides. So how about if, I'm going to indicate it like this, quantity, square root 7y plus 1 squared equals 6 squared. And on the left side, when you square a square root, we know the radical comes off, and you get 7y plus 1 equals, square the right side, 36. So we've taken this equation involving a radical, eliminated the radical, and got this nice little linear equation, which we can solve. Two things, right? We'll subtract 1, divide by 7. So let's do that. So we'll subtract 1. Right? The plan is to subtract that 1. We'll get 7y equals 36 minus 1 is 35. Let's divide by this 7. So we'll get y is equal to 5, we think. Now that 5 is a good candidate, but what we have to do is we have to check, because when you square or raise any equation to both sides of an equation to an even power, you can introduce extraneous solutions. Those are numbers that don't solve the actual original equation. So we need to check this. We need to check our work. That's one thing with these radical equations, these square root equations, we're always going to have to check. So let's do that. Let's check. And we'll do that this way. We'll say, if y is equal to 5, then, that's supposed to say then. Do you think it does? Now it does. All right, so if y equals 5, then, now take this 5, oh, what a mess. Okay, take that 5 and put it all the way back into the original equation, and then see if we get a true or false statement. So if I put this 5 back in here, we're going to have this. It'll be the square root of 7 times 5 plus 1 minus 6 equals 0. So do as much as you can in your head. 7 times 5 is 35, plus 1 is 36. So now we're here. Square root of 36 minus 6 equals 0. Square root of 36 here is 6 minus 6 equals 0. That gives us 0 equals 0, and the whole thing checks. So 5 apparently does work. So now we're going to claim that 5 is the solution. So we're going to say now, with authority, that y is equal to 5. And in number 22, look what we've got. We've got a square root equaling a negative number. Now, when we solve these radical equations like this, we're dealing only with real numbers. So right now, we're going to say, this can't happen in real numbers. You can't take the square root of something and get negative. So right away, I can see that there's no solution to this. So because I know that, I can write no solution. But what would happen if you didn't recognize that? Let's just keep going as if we didn't know that this was true. So the next thing we would do would be to square both sides, because that radical is isolated. So we could square both sides. It would look like this. Square root 5x minus 1 squared equals negative 3 squared. And on the left side, you square the square root. The radical comes off. You get 5x minus 1 equals, you square that right side, negative 3 times negative 3 is 9. Let's add 1. We'll get 5x is 10. Divide by 5, we'll get x equals 2. But now, that's a potential solution. We need to check that. And we're going to say we check it, and here's how we do that. We say if x equals 2, then, okay, now take that 2, take this 2 and put it back up here in the original. Don't put it anywhere here. We could have made an error down here. Put it back in the original. So I'm going to put 2 right there. So we will get square root 5 times 2 minus 1 equals negative 3. Now do as much as you can here. 5 times 2 is 10. 10 minus 1 is 9. So now we're here. We're at the square root of 9 equals negative 3. But look, this has got the radical on it. We know that 9 has 2 square roots, 3 and negative 3. But when you put that radical on it, we're talking about the positive one. So this right here is 3. So now we get 3 equals negative 3. Well, that's false. So this doesn't work. So 2 does not work. So we can toss that out. And now what we'll say is we have nothing left. So now we'll say no solution. Let's take a look at 23. We've got a radical equation again, and we know what to do. We're going to isolate a radical, so maybe we'll isolate this. Let's get rid of this x. Let's add x to both sides. So the plan is to add x, so let's do it. We'll get square root x minus 1 is equal to, now I'm going to add x, so I'm going to get x minus 1, right? If I add x, I'll add it over here. Okay, now square both sides. Get rid of the radical by squaring both sides. So we'll get this quantity. Square root of x minus 1 squared equals quantity x minus 1 squared. And on the left side, you square the square root, the radical comes off, and we get x minus 1. On the right side, okay, we got a pattern for this, right? Let's talk our way through it. Square the first, x squared. Multiply these two together, negative x, but you double it, so minus 2x, and then you square the last, plus 1. Now this is quadratic, right? We got a squared term. We know how to solve quadratics. We get everything on one side, 0 on the other. So why don't we do this? Why don't we subtract x, add 1, right? So I'm going to subtract the x, add the 1. I'll get a 0 on the left, and then we'll get x squared, and then negative 2x minus x minus 3x. And then we've got a 1, and you add 1, so that'll give us plus 2. There's a quadratic equation we can solve, we hope. We'll factor, and I think it does factor, doesn't it? X and x, a 2 and a 1. The 2 is positive, so these numbers have the same sign, which is that middle minus sign. Minus, minus. So from here, we're going to get two solutions. We're going to get x equals 2 and 1. Now, we think that these are going to be solutions. They're potential anyway, but we need to check them, right? Because we raised both sides of an equation to an even power, so we need to check. So let's check these. So I'm going to write it like this. Check, and I'll do this one. If x equals 2, then, all right, so let's take that 2, put it all the way back up here in the original, here and here, and let's see if we get a true or false statement. So doing so, we will get square root of 2 minus 1 minus an x, which is 2. That's equal to negative 1. So where are we here? 2 minus 1 is a 1. Minus 2 equals negative 1. Square root of 1 is 1. Minus 2 equals negative 1. 1 minus 2 is negative 1 equals negative 1. This thing works. It's true. So 2, this one is going to work. Now let's try the 1. So we'll check that one. And I'll say it this way. If x equals 1, then, okay, if x equals 1, then let's put that 1 all the way back up here in the original, here and here. Here's what we're going to get. How about square root of 1 minus 1 minus 1 equals negative 1, right? You see what I did here? I took that 1 and I put it here. So 1 minus 1, and then minus, I put it here, 1. So this gives us the square root of 0 minus 1 equals negative 1. Square root of 0 is 0 minus 1 equals negative 1. 0 minus 1, negative 1 equals negative 1. Looks like that one works too. All right, so both of these work. So now let's just conclude that our solutions to this equation are x equals 2 and 1. Both of those work.